In the second review section in our basically algebra review in chapter A, we are going to review how to simplify algebraic expressions. Every single day in this class, we're going to be working with algebraic expressions. So it just means things that have variables in them in various formats. So, x to some kind of power, maybe we even have a fraction involving x to powers. And so it's important that we are pretty good, if not masters, at using algebraic laws and properties. So the first thing we're going to review is exponents. So there are several different kinds of exponents that you can have. The first and most kind of basic kind of exponent is a positive exponent. So when we write something like x to a power, and I'm just going to use p to represent any kind of numerical power that we might encounter, what this is a shorthand notation for is repeated multiplication. So, we do x times x times x. I don't know what p is, what number that is, it can be anything. But we just multiply x by itself, right, p times. So this is just what we mean when we write x to a power. That is a positive number. Zero exponent is a special case. Zero is not a positive number, so we have to kind of separate that out. And x to the zero power, any number to the zero power is 1, unless x equals 0. That is actually a totally separate case that we're not going to really encounter. So no need to worry about that. Any number aside from 0 to the 0 power is 1. Then we can also have negative exponents. So if we write something like x to the negative p, and again, I'm using p as a placeholder for any number in general, it's kind of weird to think about what raising something to a negative power means. We use this as a shorthand notation to mean actually a fraction. So instead of writing x to the negative p, we can also write this in its fractional form, which would be 1 over x to the positive p power. Now, some people like to think of this as we have this negative sign here that kind of just becomes the fraction bar. Not really, but this might be a helpful way for you to remember that that's what a negative exponent means. So this is a really quick example. If we write something like x to the negative 3 power, right, this is the same as 1 over x to the positive 3 power. And something to point out here, if we've got a number in front of the variable in front of the x, so for example, how about 2x to the negative 5th? That negative I power is only on the x. It is not applied to the 2. So when this is the case, the 2 does not come down into the denominator like we have over here. The 2 has to stay up top, kind of like the 1 did, in this previous example where that 1 was basically understood to be multiplied by the x to the negative 3. So this is 2 over x to the positive 5th, not 1 over 2x to the 5th. All right, our fourth kind of exponent can be representing something that is a root. So roots look like this. Radical form, radical notation would be written like this. This without a number here, this represents the square root. But in general, we could have the third root or the fourth root or any kind of root, the 100th root. And so when we want to talk about roots other than square roots, we put a number where I'm placing this r right here. And just say it, so this would be the rth root of x. This notation can get a little clunky, and there's actually another shorthand way that we can represent this. This is where we get into fractional exponents. So the rth root of x can be rewritten as x to the 1 over r power. X to the 1 over r power. And as we're working with these kinds of expressions in calculus, and you'll see why when we get there, but you just have to trust me for now that these kinds of notations, just having x to a power in the numerator with no fractions, they're going to be a lot easier to work with. So These are equivalent on either side of the equal sign, but depending what you're doing, you might want to use one form over the other. So an example of the rewriting with a root, if we have just the square root of x, and it's understood that this is the second root, and so this is the same as x to the 1/2 power. All right, our last kind of exponent that we can have is also a fractional exponent, but maybe the numerator in the exponent is not a 1 like it was here. So what does that represent? Well, that is if we have the rth root of something underneath that is not raised to the first. So the rth root of x to the p for power, r for root, the way that this would be written in fractional or exponential notation would be x to the p over r. Exponent notation, x to the p over r. So as a really quick example, if we are looking at the third root of x squared, this would be the radical form of this, or radical notation for this. Another way that we could write this, now it's x to the power over root. We have x to the second power, and it's the third root. So this would be x to the 2/3 power. These are all the kind of exponents that we are going to encounter that represent a variable to a numerical power. Later at the end of the semester, we will talk about exponential functions or exponential expressions, and those are where you have a number to a variable power. But for now, all of our exponents that we're talking about at this point are going to be numbers on variables. All right, the second kind of chunk of things that we're going to review is how we combine things with exponents. So I'll call this operations with exponents. So the first operation that we can do with exponents is how do you combine things together if you're multiplying two things that have the same base? So multiplying like bases. So for example, if we have the same base x to some kind of power, I'll use m, and then we're multiplying that by x to another kind of power, I don't know, I'll use n. Then the way we can combine these together into x to a single power is by adding the exponents together. So this would just be x to the m plus n. Having one x in one spot is better than having two in two different spots. So we always want to be able to simplify and combine powers of x together when they're multiplied in this way when possible. So for example, if we have x squared times x cubed, and this would be x to the 2 plus 3, and so that would be x to the 5th. On the other hand, when we are dividing like bases, so in general, we could write this as x to a power, x to the m, divided by x to another power, let's say x to the nth power. In this case, we subtract the exponents. You could see this if you wrote out the number of times that you multiplied x by itself on the top and in the bottom, and then canceled out all of the x's that you could. What you would end up with, the number of x's you have left over, would be whatever was in the top, the exponent m, minus the number that was in the bottom. So x to the m minus n. So for a quick example here, if we have x to the 6th over x to the 3rd, right, it's the upper exponent 6 minus the lower exponent 3, and so that will give us x to the 3rd power. All right, the third way of combining things with exponents is kind of less combining and more removing, and I would call this removing parentheses. So there are 3 different ways that we can remove parentheses in an expression. So for one, if we have a product, x times y to a power, we won't want to have those parentheses there. Then what this really represents is x times y times itself, n times. And so you'd have x times itself n times, and then also y times itself n times. So this can be rewritten the same as x, oops, it's a little tiny, x to the nth times y to the nth. Again, these are equivalent. You might want to use one form over the other in different situations. We should be able to go back and forth, left to right and right to left. All right, the same thing is true for division. So if we have a quotient raised to a power, this is the same as the individual parts of the quotient raised to the individual powers and then divided. Okay, and then our last way of removing exponents, that's not right, removing parentheses, is when you have something raised to a power. Okay, so in this case, here's where we multiply the power. So this would be x to the n times m. All right, something that I want to draw your attention to is some things that a lot of students make some common errors with. So if you notice these two kind of operations here, where you have a product to a power and a quotient to a power, these two things do not generalize to plus instead of times or minus instead of times. Okay, so don't, that's not a rule here, as we didn't write it down. So, but sometimes it seems like it should work, but in fact, it never does. So be careful when we have things like x plus y to the nth power. Or minus, so we can put a minus here as well. This is not the same as x to the nth plus or minus y to the nth. Now let's just look at an example, because I know it's a little hard with some variables and lots of letters. So if you have, say like x plus 3 squared, right, what I'm saying here is this is not the same as x squared plus 3 squared, which would be 9. Right, so what you'd have to do to figure out what x plus 3 whole thing squared is, you have to FOIL that out instead. Right, so for FOILing, that's like first, outer, inner, last. So we'd have to do, x plus 3, parentheses, x plus 3. And we would get this middle term, right? We've got first, so that's x times x, that's x squared. We've got, what's the O, outer, so that's x times 3, that's 3x. Inner, we've got another 3x. Combining those together, that's 6x. And then the last term's 3 times 3, that gives us 9. And so when you don't do this, you're forgetting about this middle term here, and it's very important. So just be wary of that mistake as you're working with algebra throughout the semester. So in the next video, I'll go through some examples with you on simplifying things and using all of these properties together.